Hello everyone and welcome back. Today we will finish our look at simplifying rational expressions and rewriting rational expressions. You'll notice that, again, a rational expression is just a polynomial over another polynomial, and you just want to simplify it, looking for common factors. So we'll have to factor things and stuff like that here. So looking at letter C, all right, we can see that the numerator, there's not really anything we can do to factor that, so it's just going to have to stay at 3 minus x. So we'll rewrite that, 3 minus x. Okay, and then in the denominator though, x squared minus 9, that is a difference of squares. We can think of that, if you want to, as x squared plus 0x minus 9, and we can use the product sum. Two numbers that multiply to make negative 9, but add to make 0. Pause the video and think about what two numbers multiply to make negative 9, but add to make 0. And the answer is 3 and negative 3. So this would factor to x plus 3 and x minus 3. Now, looking at what our factored rational expression looks like here, right, we see that these are almost common factors, but they are not exactly the same. This has a positive 3 and a negative x, whereas this has a positive x and a negative 3. So in other words, these two things are exactly opposites of each other. Can we do anything to remedy this? And the answer is yes. If we take a negative 1 out of the numerator, we'll get negative 1 times negative 3 plus x. Or, written another way, x plus negative 3. Or, written another way, x minus 3. So 3 minus x is the same thing as negative 1 times x minus 3. Which then, when we bring over our denominator, we can see, aha, these exactly cancel now. So cancel those out, and we're left with negative 1 over x plus 3. And there's our simplified version. Again, take your original denominator, set each of those equal to 0 to find the x values that would cause us to divide by 0. So subtract 3 on both sides, you get x equals negative 3. And here, add 3 on both sides, you get x equals 3. So again, for these, we don't want x to be those values. Okay? All right. Last one here. This one has x's and y's in it. So let's see what we can do. In the numerator, right, there's a GCF we can factor out. A GCF of what? Of 3. So we'll put 3 times x minus y over. And then what about the denominator? Does that factor? Well, this is a little bit hard to see because we have both x's and y's in here. Okay, a little bit different than what we're used to seeing. But we can figure out a way to make this work, or to factor this. So again, think about here. Okay, it's pretty much a quadratic, right? You have a squared term and then a middle term and another squared term here. So let's see if we can figure out, how to factor this thing. So we need a y, and we'll need a y. Actually, I'll go ahead and just do it here over the problem. Okay, we need a y and a y. We also need two x's, right? So I could put x and an x here, and that would create x squared. And I could put plus x and plus x. If I multiply that out, though, I'm going to get a yx and another yx, which would be a positive 2yx. I need a negative 2yx. How can I get that? Well, instead of a positive x, let's do minus x and a minus x. Negative x times negative x will still give us an x squared. Okay, but it also gives us that negative 2xy, because it will be negative x times y, negative xy, and another negative x times y, negative xy, and so that gives us negative 2xy. So there's our answer. Okay, again, looking at this, you'll see that this is almost the same as that y minus x down there, but it's not exactly the same. They're exactly opposites. Again, where the x is positive, this x is negative. Where the y is negative, this y is positive. So what can we do? Well, the same thing we did before, right? Where we had the 3 minus x and we factored out a negative 1, we'll do the same thing. So go ahead, finish the rest of the problem. Factor out a negative 1, and then cancel, and find those x values that don't work. Okay, so hopefully you pause the video there. If you factor a negative 1 out of the numerator, you're going to get negative 3 y minus x, like this, over y minus x times y minus x. Cancel the y minus x with the y minus x there, and we're left with the negative 3 over y minus x. So there's our simplified version, and we'll just set each of those factors equal to 0. Since they're the same factor, you only need to solve one. So we'll just solve this one right here. Add x to both sides. You get y equals x. So in other words, we do not want y to be x. Otherwise, we get 0 in the denominator. Okay? Here's a little brief summary for you about how to simplify rational expressions. If you can, again, get a common factor in the numerator and denominator, you're able to cancel those two things out and just simplify down to a over b. Okay, and again, just understand that for rational expressions, okay, the rule for simplifying rational expressions is the same as the rule for simplifying integers, rational, numbers with integers and stuff like in the numerator and denominator, but requires the domain of the rational expression to be restricted. Okay, so we have to look out for x values that would cause us to divide by 0. That's why we put these, domain restrictions here. Restricting x values is restricting the domain, right? So all those little guys. All right, thanks for watching, and we'll see you in the next lesson.